everyone. Thanks a lot for joining us today. Thanks a lot, Nike, for explaining about foundation level HTTP. My name is Yosef Aitkin. I'm co-CEO and co-founder of TechPro globally. And today I would like to talk about two additional certifications that I believe are relevant for software testers. They are HTTP AI testing and the number of HTTP Agile testing certifications. So I'll start with the portfolio of certifications and we'll compare different syllabi. We'll cover what skills are specific for Agile testers and what are the challenges specific for AI systems and why study AI and Agile testing training courses, update certifications, etc. So this is the portfolio of ISTQB certifications. It has foundation level covered by the training course introduced in Georgia. It also has 3 pillars. One is Agile, another is Core, and another one Specialist. So in Specialist, today we'll cover AI testing, and in Agile we will look at all 3 certifications that are available. So here's Agile testing certifications were introduced first in 2014. There are 3 of them. One is required for 2 others. It is called Agile Tester Foundation. Then there is Agile Technical Tester and Agile Test Leadership at Scale. This is a comparison of different syllabi. So it contains 4 columns: the name of certification, number of meaningful pages, and the date of the last update. So following the question that was asked, how frequently different exams are updated. Foundation level was updated last time in 2018, so 4 years ago. There were introduced substantial changes in comparison to the previous version that was published in 2011. AI testing certification is very new. It appeared at the end of 2021. Foundation level Agile testing is from 2014. Advanced level syllabus for Agile Technical Tester is 2019, so more recent. And Agile Test Leadership at Scale is extremely new. It was published last month. And it is still work in progress, so certification only available in 4 countries, including Sri Lanka. And the syllabus itself is currently 6 pages. Okay, the last column here is related to number of times the word Oracle present in the syllabus. And we will get back to that, but you can see that the only course that covers it in more or less that covers it is AI testing. foundation level, advanced test automation engineer, etc. They have only a couple of references to test oracles. So this is the basic foundation level agile tester exam. It consists of 3 pillars. The first one is related to describing the content of Agile Manifesto and Agile principles. So it is Agile software development. It is not necessarily related to software testing. It describes development process. The second pillar that I will comment later in the presentation describes principles and practices related to software testing. It tries to address the difference between testing in traditional and agile approaches, status of testing, roles and skills. And the last one goes into more details in particular methods like TDD, BDD, etc. It also worth mentioning that the last part intersect with the another certification that is advanced level agile technical tester. So the last part of foundation, it is subset of a separate advanced level certification that covers requirement engineering, testing, test automation, and deployment options in Agile. So here is my favorite part from foundation level Agile tester. It starts with the following quote: a tester on Agile project will work differently than one working on traditional project. And now we will look into more detailed information that syllabus gives on the subject. So these are Agile tester skills. Be positive and solution-oriented with team members and stakeholders. Display critical, quality-oriented, skeptical thinking about the product. Actively acquire information from stakeholders rather than relying entirely on written specifications. Accurately evaluate and report test results, test products, and product quality. Work effectively to define testable user stories, especially acceptance criteria, with customer representatives and stakeholders. Collaborate within the team, working in pairs with programmers and other team members, respond to change quickly, including changing, adding, or improving test cases. Plan and organize their own work. It is very difficult to spot here anything that is not required for any software tester. So if we just remove the term agile, it will be tester skills. And it is one of the important aspects of agile software testing specification. It tells more about what is required from software tester rather than about agile specifics. My colleague, Dr. Ivorsky, will cover skills for software testers in more details later today. But the main thing is continuous skills growth, including interpersonal skills growth, is essential for all testers, including those on agile teams. So from this slide, there is no difference between agile, what is required from good agile tester, and from any good software tester. And the same thing go here is for the role of a tester in Agile team. So if I will just remove the second part of the title from syllabus and we'll try to read it, we'll see that it exactly applies to any software tester in any team. Like understanding, implementing, and updating the test strategy, reporting defects, and working with the team to resolve them. So I believe these are evidence that there is no difference between agile testers and testers. There are good software testers, there are bad software testers. And things like that, they can be covered in foundation level syllabus because they are not specific to any context. Agile is context for software testing. It is not a specialty or separate specialty, separate skill. Good software testers are agile software testers. Okay. Now we are switching to the second certification, that is Advanced Agile Technical Tester. As I mentioned, it covers the third pillar of the foundation level certification. And looking at the contents of the advanced certification, what we have there, we have a good section on requirements engineering specific to user stories. Then we have testing in Agile that covers TDD, BDD, ATDD. And experience-based testing, including exploratory testing. Test automation part is similar to what was previously present in foundation level syllabus in 2011. For some reason, it is now part of Agile Technical Tester. And the fourth section is dedicated to deployment and virtualization. So what about TDD or test-driven development and unit testing? So the thing about unit testing or test-driven development is, where it is? Here it is the same as the relation between guinea pig or C pig and the C, guinea, and pigs. Guinea pig is not a pig, it doesn't live in Guinea, and it also has nothing to do with the sea. The same thing is test-driven development, despite the fact that it contains the word test, it has nothing to do with software testing. So if you look at what is covered in the second section, things like TDD, BDD, unit tests, agile testing quadrants, they are not related to software testing. They are related to something else. Software testing is exploring software with intent of finding bugs. All testing is exploratory testing, and software testing is empirical technical investigation conducted to provide people with information about quality of the product or service under the test. Yes. So here's the QR code. I do recommend everyone to read the definition. Exploratory testing is a redundant term because all testing is exploratory. Software testing is not the same thing as software development. Software development is taking an abstract model or design concept and turn it into something useful, like useful product or service. And software testing is looking at software or other artifacts and obtaining and building a model. So we have two parallel processes, but one of the processes uses a model to build something useful, and another process is using something useful to build a model. These are two parallel processes that have anti-parallel flow of information. And it is very important. So when we talk about software testing, we are not talking about software development. So the sections dedicated to the things like TDD and BDD should be in software development manual, not in software testing. Development and testing are two different processes. Good to know. Now, to understand what unit tests are, it is necessary to read the definition of software. So what is software? Software is a collection of instructions and data that tell a computer how to work. The computer, hardware, is able to execute the software. Each instruction causes the computer to carry out an operation, move data, carry out computations, alter the control flow of instructions, or manipulate hardware. So this is the definition of software. And if you think about what unit tests are, you will see that unit tests are software. They are not tests, they are software, because they are a collection of instructions that tells computer how to work, and they involve altering the control flow of instructions and manipulating things. There is a very important concept of CI/CD, continuous integration, continuous deployment. If you think what CI/CD is, CI/CD is running software. So it is the software that launched and continuously operate. And then, depending on the output of the data, it makes alterations to the control flow. So TDD, BDD, etc., and CI/CD are software. How do we call the process of creating software? We call it build software. So creating unit tests, writing BDD scenarios, writing ATDD scenarios is writing software. So what we have on the left is building software. It is less so on the right. What we have on the right, exploratory testing. And as I mentioned previously, all testing is exploratory testing, and exploratory testing is testing. So what we have on the right is testing software. Of course, to do it at any scale, one needs to rely on tools to support it. So what one needs to do is to build software, to test software. But build software to test software is not the same as writing unit tests or creating BDD scenarios. Okay. The next one. Another of my favorite quotes, it says, the team should be relatively small. Successful teams have been observed within as few as 3 people and as many as 9. So it is, this one is present in ISTQB syllabus. It is difficult to interpret it, so does it mean that no successful teams were ever observed with more than 9 people, and it also probably means that no marriage is successful because most of the marriages include less than 3 people. Okay. Personally, yes, it says that successful teams have been observed. Yes. Okay. Maybe. Yes. Sure. I'm thinking I'm more interested in large-scale implementations that require more people because more people can create more things, and that's why the certification targeted specifically at large-scale agile implementation sounds very compelling to me, but if we look into what is covered currently in this very new, so it is certainly work in progress. So there is even no fourth pillar for advanced level agile test leadership at scale for large scale implementations. We will have quality assistance, improving quality, and continuous improvement of quality. And software testing at scale is not quality assurance. Software testing is not quality assurance. Here is QR code, and here is a seminal paper from 2010 that explains software testing is not quality assurance. And software testers should get out of quality assurance business. If you want software developers to have good code, you can become a supervisor for software developers or write code yourself. Go into software development in software development leads. If you would like to structure the process of quality, you can go into management and try to organize, fire people who are against quality, hire people who are for quality. If you want to preach quality, that quality is important, you can go into quality evangelists or a preacher and tell everyone that quality is important. But software testing is not about improving code, it's not about managing quality, and it is not about coaching others on the importance of quality. Software testing is about finding defects. Defects is information about something present in software that decreases its value. And software testing is important because it gives people what they need, and they need information. So there are many good professions. Doctors, lawyers is not a good profession, but there are many other good professions. Firefighters. But teachers, even teachers, yes, teachers is very good profession. But software testers should do software testing. We value firefighters not for their ability to tell kids not to play with fire. They can do it, but if instead of fighting fires, they will spend all of their time, or most of their time, talking to kids about not playing with fire, they become teachers. And teacher is extremely noble profession, a good profession, but it is not the same as firefighters. Teachers are important, firefighters are important. Software testers are important. So this is where I have some doubts on the large-scale testing syllabi. Software testing at scale requires a process, it requires platforms, it requires people, but it is software testing. It is not preaching quality. Software testing is information service. It should be measured on its accuracy, relevance, interpretability, accessibility. And talking about data, we now will switch to the next certification, and talk why it is important. It is AI testing. AI testing was introduced very recently at the end of 2021. It covers many important, interesting topics. Probably it is not possible to see it from the screen, but you can always go to ICTQB website and you will see that it should cover everything. It covers ethics, evolution, metamorphic testing, neural networks, everything. Great content. So there are 3 things a software tester can learn from AI testing syllabus. 3 things. And in Tbilisi, we are working on the next training course that will be specifically on AI testing certification. So what are the 3 things and why they are important? The first one is, of course, AI. The second one is testing AI. And the third one is AI testing. So why AI is important? AI is important because probably very soon everything around us will be software. And most of it will contain one or another type of AI technologies. So AI is important for every engineer, including software testers, because most of the things around us will soon be AI, and everyone, most of the people, recognize the importance of it. So, European Commission is working on releasing Artificial Intelligence Act that I hope soon Georgia also will become part of European Union, or at least will have to normalize regulation to be compatible with EU legislation. And Artificial Intelligence Act clearly states that it is good for, AI is good for citizens, good for business, good for public interest, but contains risks for the safety of consumers and users, and also for fundamental rights. Different fundamental rights, but one of the most fundamental rights is the right for life and for freedom. So it is very important to understand what's going on in AI field for everyone, and especially for software testers. Then we are going to the second point. So the first one is AI, the second is testing AI. And AI testing syllabus says the following. In a typical conventional computer system, the software is programmed by humans using an imperative language. It includes constructs such as if, then, else, and loops. And then the statement that I'm not necessarily agree with, it is relatively easy for humans to understand how the system transforms inputs into outputs. I believe that everyone who has ever met any complex software system knows that it is not relatively easy for humans to understand what's going on. So there are many things that are difficult about ordinary conventional systems. Let's look at how AI syllabus defines the challenges of testing self-learning systems. So these are the challenges: unexpected change, complex acceptance criteria, insufficient testing time, resource requirements, insufficient specification of operational environment, complex test environment, undesirable behavior modifications. So everyone at all who had ever met the complex system and who ever participated in software testing for a complex, large-scale system knows that all points here are applicable to such a system. And the same goes another section in AI testing syllabus, data quality issues. It lists what can go wrong with the data. Raw data, incomplete, mislabeled, insufficient, obsolete, irrelevant, privacy issues, security issues. It is true for any important system that contains data. My point is that many things that are present in AI testing to understand how to test AI is good to understand how to properly test conventional systems. Techniques such as metamorphic testing, reconciliation testing, non-deterministic behaviors testing, etc., they are all relevant to conventional software. And yes, and another point, in the same European Commission Artificial Intelligence Act, they created addendum describing what systems are considered to be artificial intelligence technologies. And when we were studying it, we found out that most of the systems can fall under this law definition. So the last one is contains statistical approaches, Bayesian estimation, search, and optimization methods. So we are taking stock exchange, matching engine, or trading gateways. They all contain search and optimization methods, for example, in auctions. And you will look at almost any system, you will see that it is there. To properly test it, we need advanced techniques. And advanced techniques are not necessarily covered in foundation level syllabus or agile testing syllabus or test automation syllabus, but they should. Another evidence, for some reason, people taking AI testing more seriously than conventional systems testing. Why is that? Probably because AI is considered to be a new and unknown thing, and that's why humans are afraid of artificial intelligence and pay more attention. So my main evidence of why people are not taking software testing seriously is from using term test oracle. So test oracle is something that allows us to define if something deserves attention in the software. And it is a very foundation concept in software testing. But now, if we look at all the syllabi available from HTTP, we will see that it is not present anywhere. It is not present in foundation level, so there are only two references. It is not present in test automation. It's not present anywhere, apart from AI testing, because people are afraid of AI, and that's why they believe that it is necessary to test it properly, in contrast to all other systems. And the last thing, so I mentioned AI, testing AI, and AI testing. Why it is very important to read about AI testing, about applying AI to software testing. Because it gives you a proper understanding of what automation is. When people think about automation in terms of unit tests, etc., they do not understand what they are talking about. So automation is technology by which a process or procedure is performed with minimal human assistance. To better understand test automation, you need to understand autonomy. You need to understand autonomy models. And studying AI helps to better understand what is fallback, what is automated controls, and what is the relation between humans and autonomous systems. I believe it is very important for software testers to pay more attention to study AI testing, not just to apply AI in testing, but to better understand what is feasible from automation perspective, what is not feasible, and what are the areas we should work on. Conclusion. Ideas from HTQB AI and Agile certification can help you with conventional testing. And also, most of the projects going forward will contain Agile development methods and AI software. So it is a very good idea to study, maybe pass some of these exams. And ideas, not ideas, but statements that I have on both syllabus and in principle. Unit tests and CI/CD is software. TDD, BDD, ATDD is software development, not software testing. Software testing and software development are two different processes. Testing in Agile context is still testing. It is exploring software with the intent of finding defects and providing information. Artificial intelligence is software, and testing AI is software testing. Understanding autonomy is necessary to understand automation in testing. So I highly recommend you to have a look, and thank you very much.